Okay, today we're going to practice how to add and subtract fractions using the equation method that we've been talking about in class. So in your math notebooks, you need to add the date, 1/27/16, and adding and subtracting fractions equation practice. You can't quite see the full word fractions because the way the camera is set up, but you're going to add this to your table of contents, and you can rewind the video if you need to go back and look at the table of contents title. I'm going to go ahead and turn to that page in my notebook. And we're going to start with just a simple equation to solve. The first one that we're going to do is 3 2/10 plus 1 1/5. So the first thing I want to do is set up my mixed numbers vertically.
Miss Eccles, if you're in the building, please call the office. Miss Eccles, call the office.
Right now my numbers are set up horizontally, so I'm going to put 3 2/10 plus 1 1/5, and I'm going to set it equal to my new common denominator. I can't forget about my tag-along whole number. That number doesn't change, it just stays the same, but first I'm going to try to figure out my new common denominator. So 10 and 5, I'm going to think, what multiple do they share? Remember, multiple means when I count by those two numbers, what number will I get that's the same? So if I don't know that off the top of my head, I can make a list. I can write 10, 5, and count by each of those numbers. So 5, 10, 15, 10, 20, 30. I see that they both share a 10. So that means that is my new denominator. I'm going to put that here. Okay. Sometimes you'll have to go beyond just the first three multiples. Sometimes you'll find it on the very first one. But it's the one that it's the multiple that both of your current denominators share. So I'm going to think to myself, what did I do to 5 to get to 10? Well, I multiplied by 2, and whatever I do to the bottom, I have to do to my numerator. So I'm going to multiply by 2. So 1 times 2 is 2. And that makes this equal 1 whole, because I can't forget about my whole number over here, and 2/10. That is an equivalent fraction. Now, what did I do to 10 to get to 10? I multiplied by 1. So I'm going to multiply my top by 1. 2 times 1 is 2. So that makes this fraction, or mixed number, 3 2/10. Now I can add them because they have the same denominator. Numerator plus my numerator, 2 plus 2 is 4. I keep my denominator the same. I don't add these numbers. I don't do anything with them but keep it the same. So I have 4/10. My whole number plus my whole number, 3 plus 1 is 4. So I get the answer 4 4/10. Okay. Now we're going to take a look at some word problems. And these are more commonly what you're going to see on your test next week. We're going to look at question 1 first. It says, in order for a train carrying animals to a zoo to leave the station, its last car needs to hold exactly 14 1/5 more tons. Leroy, an elephant, weighs 6.5 tons, and another elephant, Bud, weighs 7 2/3 tons. If these two elephants got in that car, would it meet the requirement? So I'm going to go ahead and do cubes down the side. I'm going to circle my important numbers. I have 14 1/5. I have 6.5 and 7 2/3. I'm going to underline my question. If these two elephants got in the car, would it meet the requirement? And I'm going to box my keywords here. Okay. In order for the train carrying animals to a zoo to leave the station. So in order for a train to leave the station, its last car needs to hold exactly 14 1/5 more tons. Leroy, an elephant, weighs 6.5 tons, and another elephant, Bud, weighs 7 2/3 tons. If these two elephants got in that car, would it meet the requirement? Okay, I'm going to think to myself what kind of equation I need to write here. I've boxed my key math terms right now. 2 elephants got in the car. Now I need to think of an equation. So it needs to hold exactly 14 1/5 tons. I have 6 1/2 and I have 7 2/3. I'm going to have to add the weight of these 2 elephants in order to figure out if it equals exactly that weight. So my equation needs to be 6 1/2 plus 7 2/3. I can see right now they don't have the same denominator, so that means I'm going to have to do some work to solve this. I'm going to do that work in my notebook. So you guys can go ahead and write question 1, day 105. Okay. And again, that equation was 6 1/2 plus 7 2/3. Again, I'm going to write it horizontally, or excuse me, vertically. 6 1/2 plus 7 2/3. I'm going to make it equal to a fraction that has a common denominator. And I have the denominators 2 and the denominator 3. And I have to think what multiple they share. If you know it in your head, then you don't necessarily have to make the list, but it's always good to make the list just to double check yourself. So 2, 4, 6, 3, 6, 9. Okay, I see that they share a 6. That's the multiple they share, so I'm going to make that my new denominator. So I'm going to think 3 times what gave me 6? 3 times 2 gave me 6. So I have to do the same thing to the top. Times 2. So 2 times 2 is 4. That gives me the new equivalent fraction of 7 4 6. Where did the 7 come from? It's that hang-along whole number that was over here. Okay? And I just put it back with my equivalent fraction. Now, what did I do from 2? What did I do to the number 2 to get to 6? Well, I multiplied by 3. So I have to do the same thing to the top. Multiplied by 3. 1 times 3 is 3. So I get the new equivalent fractions, or mixed numbers, 6 3, 6. The 6 was my tag-along whole number from the beginning. Okay? Now I can add these two numbers. 3 plus 4 is 7. And I leave my denominator the same, 6. 6 plus 7 is 13. So I have 13 7 6. I needed, according to my problem, I needed to have 14 1/5. Well, I don't know if this is equal to 14 1/5 simply because I haven't converted this called an improper fraction because it has a bigger top number than bottom number. I haven't converted it to a mixed number just yet. So I can turn over, because I'm out of room on this page, to the back of my page and see if when I convert this to a regular mixed number instead of a whole number and an improper fraction, if it equals what I need it to equal. So 13 7 6. I'm going to turn over because I'm out of room. If you still have room on your front, you can keep writing. So 13 7 6. I have to figure out what that equals. Well, my whole number 13 is good to go. I'm just going to set him over here to the side. But 7 6, I have to think to myself, how many times will 6 go into 7? Okay. 6 into 7 only goes one time. Okay. That means that one time that it goes into 7 is another whole number that I'm able to make. So it goes in one time. So I add that to my whole number that's already over here. So that gives me 14. Okay. Then I have to think how much is left over when it goes into that one time. 6 goes into 7 one time. Basically, it's doing this equation. It only goes one time. I subtract 6, and I have 1 left over. That's my new denominator. So when I subtracted that 6, I had 1 left over. So I have 1 as my new numerator. Not denominator, I'm sorry guys. 1 is my new numerator. So 1, and then I keep my current denominator. 14 and 1/6 is my answer. According to the problem that I was trying to solve, the cart had to hold exactly 14 and 1/5. 14 and 1/6 is not equal to 14 and 1/5. So, in order to answer the question, if these 2 elephants got in the car, would it meet the requirement? No, it would not meet the requirement. Okay, we're going to look at one more question, and then I'm going to use the other 2 questions for us to practice together in class. So we're going to look at question 2 here. I'm just going to fold this over so we can focus just on question 2. Whoops. An adult Asian elephant can grow to be as tall as 9 8/10 feet from shoulder to toe. An adult African elephant can grow to be as tall as 13 feet from shoulder to toe. How much taller can an adult African elephant grow to be? I'm going to go ahead and put cubes here to help me solve it. So I'm going to circle my important numbers. 9 8/10, 13. I'm going to underline my question. How much taller can an adult African elephant grow to be? I'm going to box my keywords. Asian elephant, grow to be as tall as 9 8/10 feet from shoulder to toe. An African elephant can grow to be as tall as 13 feet from shoulder to toe. How much taller can an adult African elephant grow to be? Okay, and now I need to evaluate an equation. So it's asking how much taller is the adult African elephant than the adult Asian elephant. This means subtract because it's asking me how much taller. So I'm going to subtract 9 8/10 from 13. 13 minus 9 8/10. Now I need to solve in my notebook. So I'm going to write question 2 right here. Day 105. And my equation is 13 minus 9 8/10. Right now my 13 has no denominator at all. So I'm not gonna let that throw me off. I'm just gonna write it vertically. 13 minus 9 wholes 8/10. Okay. And before I can find a common denominator, I need to go ahead and get a denominator for this right here because it has nothing. We talked about being able to borrow from our whole number, and that's what I'm going to do. Okay. I'm going to take this 13, turn it into a 12, and that means I reduced it by 1 whole. Well, I got to think, what fraction could I create over here that's equal to 1 whole and has a denominator of 10? Because I want it to have the same denominator so I don't have to do extra work. Well, I know 10 over 10 is equal to that 1 whole that I just borrowed from here. So I'm going to rewrite this. So this 13 wholes turned into 12 and 10/10, or 12 and 1 more whole. I just put that whole in fraction form so that I could subtract. Minus 9 and 8/10. So my numerator minus my numerator. 10 minus 8 is 2/10. And 12 minus 9 is 3 wholes. So the adult, I'll rewrite that over here so you can see. The adult African elephant grows to be 3 2/10 feet taller. Feel free to replay this video if there was a part of it that you didn't understand. Go back, rewind it. Make sure you get all these notes in your notebook. I'll be checking for these notes tomorrow. And we'll finish the last 2 problems in class You'll be working on those with a partner along with some other practice problems. All right.